Hello, this is TJ and welcome back to my new video. In the previous video, I just make a comparison between the waterline and the finished contour toolpath about how they handle the shallow area on the part. And today in this video, I gonna talk about the cut order optimization of the toolpath. Okay, firstly, I should talk about cut order. Okay, and I have some part here. We go to this part first. This is a very simple part, and I already created some waterline and contour toolpath so you can see uh, what the cut order. Okay, first, this in the waterline section I have two waterline toolpath. The first one, no optimizing in cut order, and the second one is optimizing in cut order. For the first one, you can see the tool is cutting from the top to the bottom, and when it go to this level, it jump from this area to this area and it's finished one level before it go to the next level. So you can see there's a lot of retraction in the cut. This toolpath is not optimized, so you can see we have a lot of retraction because the cut order is by depth, so it will cut from the top to the bottom or bottom to the top. Yes, but this one is optimized, so you can see instead of cutting from top to bottom, it the cut order is sorted by area. This will finish one area before go to another area, like this one. You can see the tool finish cutting the island here, and it go to the pocket here, and after it finished this pocket, it jump to this second island. So that's the cut order optimized. And we have the same option for the finish contour. In the first finish contour, we have cutting by depth, no optimization, and the tool cutting from top to the bottom, like in the first waterline toolpath, no optimize in cut order. Okay, and the second one, I activate the optimize option, and you can see it's finished one island, go to another area before go to the last area. So this is optimized. So let's open the toolpath parameter so you can see where is the optimize cut order. Is here in the cut parameter. This is waterline toolpath, and you can see there's one option called cut order, and you have three options: by depth, optimize, or from bottom to top. If you select by depth, the tool will cut from the top to the bottom, no optimization. And if you select optimize, the tool will finish one area and before it go to another area. And if you select bottom to top, the tool will cut from bottom to the top, from lower to higher level. Okay, so you can see with this waterline toolpath, the cut order was by depth, so that's why it's cut from the top to the bottom, and we have a lot of retraction when it moving from this area to this area. It has to finish one depth first before go to another depth. And for the second toolpath, the cut order is optimized. That's why you can see we have less retraction. The tool finish one area and it's go to another area and go to another area. So This is waterline. And the same for the finish contour, we also have that option. This is here, you can see that option, optimize cut order. And for the first finish contour toolpath, I have not selected that option, but the second one I have selected optimize cut order, and you can see we have a better result, less retraction. Okay, so at the first look, you can see for the waterline and the finish contour, there is not so much different. It look quite well for this part. You can see the result is quite similar. You cannot see the difference, yes, because this part is quite simple. Now this is the comparison, the real comparison. We go to a more complex part like this. You can see we move to the green part here. I have two similar part. One I gonna use the waterline, and this one I gonna use the finish contour, and you can see the difference when I apply two toolpath on this part. Okay, and you can see I gonna talk something about the part. All right, you can see this part I have so many fin. You can see this some kind of cooling fin. You can see they are close together. They stay quite close together. And why I put them close together, I'm gonna show you. It's called a problem in our toolpath. Okay, and you can see I also have two islands. They are close together. Yeah, you should remember they are close together. The distance between the island is quite small. Is it different with this part? This part also have two islands, but the distance is very large, so there's no problem. But for this one, you can see we have many islands, and the distance between them is close, very low. Yeah, it's called a problem. I'm gonna show you. Okay. So the first, I'm gonna try with waterline toolpath. So I copy this toolpath and I paste it. So this one is not optimized. I reselect the cutting surface. Alright. And we keep the same value for step over, and this toolpath have not optimized. So you can see the cut order is by depth. Now let's try to generate the toolpath. Oh, sorry, I need to select the boundary. Alright. Okay. Yeah, you can see a lot of retraction, and this is cutting by depth. You can see it finish one depth, finish one Z level, and needs to go to the next Z level from top to bottom. Okay, and now we are going to optimize it by selecting optimize in cut order and see the difference. Choo! Yes, it's finished calculating. But the result is bad. You can see that after we selected optimize, the result is still bad. It's not like this part, it look great, but in this part it look bad like this. After we select optimize the toolpath, we still have a lot of retraction. Yes, there's no improvement. It's still jumping a lot between the cutting error. I don't know what card is, but in my opinion and my experience working with this waterline toolpath, I think this problem is caused because of the cutting area is so close together. They are close together, so the toolpath, I think it cannot calculate. I think it is cannot make a good optimization. I have tried to work on the gap distance, but it's not work. It does not work. For example, I'm gonna make a smaller gap distance. So I wanna keep the tool in one fin before it jumping to another fin, but it not work. I think if you have worked with waterline toolpath and the same kind of part here, you have cutting out area close together and you have the same problem with me. I think so. So you can see we cannot make anything better. It's still bad. A lot of retraction. Instead of finish one fin, go to another fin. It's just jumping a lot. Yes, and I think it caused by the distance between the cutting area. If it's too close, uh, the waterline have some problem. See that? If you try a greater value for gap distance, it not have. Okay, I don't know if I right, but I've tried a lot of things on this toolpath, but with some part like this, when machine area is close together, it has this problem, a lot of retraction, and it cannot keep the tool finished one area before going to another area. So this bad. Okay, but for the finished contour, I have a better result. We copy this and we paste it. I gonna reselect the surface and the containment. Okay, now I select this one and containment. Okay, and first this is the finished contour without optimization. Yes, because the finished contour is traditional and old toolpath, so we cannot do anything when it calculating. Yeah, you can see it's the same with the waterline. Um, Still a lot of retraction, but it look better. Now I'm gonna turn on the optimize option here, and we check the gap setting. I'm gonna input 2 mm for the gap setting. Boom, and we wait for calculating again. Now this toolpath is optimized. Let's see if it works. You can see that. I don't know, but it look better than the waterline. We have less retraction. Yeah, I know sometimes retraction is not always bad, but in this case I think the contour toolpath is better. We have less retraction. Yeah, you can see this is the finished contour after optimize, and this is the waterline of after optimize. So optimize, and this one optimize, so you can see the difference. For the waterline, even we optimize the cut order, is still a mess, because for this part the cut area is close together. I think that's called the problem. But for the finished contour, even the cut area is close together, we still have a good cutting order. You can see the tool cut finish cutting one fin before it jump to another fin. Yes, it look nice, I think. Also on these two island, even the distance is close, no problem happen. That's great, you see. Yeah, that's why, because there's something in the waterline I really don't like about it. We are very difficult to control it, because this maybe this intelligent toolpath, so we cannot anything on this. There is less option. You can see there's not so many options we can do on this. Yes, you can see this simple part there's no problem, but when we move to this part, a little complex, and we have some case here. The cut area is close together, and we found the problem for the waterline. Yes, if you have some solution for this, just tell me. I have not found any solution for this when I have some part like this. When the cut area is close, I I always have this problem. And there's one thing, and there's one another thing I want to say about the cutting optimization. Is about the cutting direction. Okay, let's see. You can see on this part I have a taper area here. I mark it in red. Okay, this red area, you can see this is an open area, and for the contour toolpath we can see it make a zigzag cut here. Even the direction is clamp. We also can make some zigzag cut here, so we have less retraction. Yeah, maybe the surface finish is not good, but the finish contour allow us to do that. That's it. We can make a combination between make a combination of one-way cutting and zigzag cutting. You can see here on the fin here there are close areas, so the finish contour is it make a one-way cut. Yeah, you can see this is a one-way cut, clamp milling, and it's the same for other area. Close area it use the one-way cutting method. Okay. Yeah, but when it jump to this red area, this is an open area, so it can make a zigzag cut, so we have less retraction here. This option allows us to do that. It's called direction of open contour. If we select the zigzag, so we can make a combination of clamp milling and zigzag milling. Or if you want to keep the cutting direction is the same, you can select one way, and we don't have the zigzag motion. But I think that's a good option for the finished contour if you don't want to retract the tool too much. Sometimes you want to use both clamp milling and zigzag conventional milling. You can see when we select the one-way cutting on the open area, you can see it will not cut in the zigzag direction. It's one way like this. You can see a lot of retraction. Yeah, and when we select zigzag, we can eliminate the the retract motion on this open area. That's the one thing I like in the contour. Finish contour is allowed to modify the toolpath to make so many chain. Yes, like this. We have some zigzag here and one way here, but you cannot do it for the waterline. In the waterline toolpath, you can only select one way of cutting direction. Clamp milling or zigzag milling, you cannot make a combination like in the finish contour. If you select one way clamp milling in the open area here, you have to have some retraction here. You can see. Yes, that's another way I like it. In the finish contour toolpath, is allowed to modify the toolpath a lot. And in the waterline, maybe is a new toolpath or is developed by a third party um, developer, so we don't have so many options on this. But the finish contour, full option. This waterline. So this is just a small comparison about the cutting order optimization between the waterline, the new waterline toolpath, and the traditional finish contour. Yeah, of course, because the waterline is a high speed toolpath, it have many cool functions like the lead in and lead out, the high speed lead in lead out, and many other cool options. But in the case of cutting order, I think it is not good at the finish contour. It's had a lot of problem, especially when you have to face with some part like this. Yeah, so I think this video just for information purpose only, because it's created by my experience and my opinion, so it's just for information, and I think it can help you in some case. All right, and I think that's enough for today's video. If you have any question or comment, or if you think there's something wrong, there's something not correct, you can give me a comment, and that helped me a lot. Okay, thank you and goodbye for now.